Luca was working on a project called TensorWork, and that was like my first like contribution. Like that is where I got started with open source and stuff. So they had TensorWork. It's the name of the company, and the project's name was Hanger. So that was where I met like all of my mentors, like Sharon, Rick, and Luca. So that is where I got like started with open source, and that's why like bringing on Luca was like a pretty good, like a pretty special experience for me, like me. So yeah, like Luca was was involved with the PyTorch community in the early days, and now he's like getting things rolling on the PyTorch Lightning community. So yeah, so like I thought maybe you could share your story of how you got like right from your early days, right? Early research days, your first stints. Yeah, that would be helpful for all of us.
Yeah, for sure. So I didn't follow a very straight path. So it's been all serendipitous. Maybe this can be useful also for as a message to you, like, even though it's not looking like you're heading in a very definite direction, the fact that you're kind of enriching yourself with different experiences is really good. So I graduated at a large number of years ago at Polytechnic of Milan in biomedical engineering. So that was 1999. So I don't know if people were born. Probably a bunch of you weren't born. And yeah, biomedical engineering was kind of the like intersection between mechanical, electronic, and the engineering applied to medicine, and that was really interesting for me. As a kid, I played with my Spectrum 48K, and then later on with PCs. So I wasn't really a programmer or coder, but I always got interested in learning like basic along with books and so on. So that was my first exposure to computers. But then actually during university, I didn't do that much. Actually, probably that's the period of time in my life in which I didn't even switch on a computer apart from like very short period of time. So at the end, when I had to do my master thesis, my professor told me, yeah, this is the book. It was a BTK manual. BTK is a visualization toolkit, and I want to speak a bit about that. It's a C++ library, which is of widespread use today as well. And I got the book for version 1.0, and that's where I had to pick up programming, I think. So I picked up programming when I was kind of 24, so very late in life. And then I did my PhD in basically computational geometry applied to blood vessels. It was a thesis on modeling blood vessels from MR and CT, so medical imaging, and kind of studying how blood flows within the vessels and how that can relate to the onset of atherosclerotic plaques and other disease states. And at that time, I was coding horribly, but kind of exploring computer graphics and how to build 3D models out of images. And that was interesting because it was my first exposure to one of the first projects who really did open source in a way that it was, you can say it was modern, because they had their dashboard. So that project came up. So testing dashboard, unit test, continuous integration. It was already there in 1999 for that project. That project came out of a experience at GE. GE is a company that did, medical, a lot of things, among them scanners and so on. I don't know if you ever heard about the Marching Cubes algorithm. It's an algorithm with which you extract isosurfaces of scalar fields. And the creator of the marching cube algorithm, Bill Lorenzen, started BTK as an exercise. I think at some point he told me, because when I got to know him, he told me it was more of a application of Six Sigma high quality software quality experiences within GE, but then it took a life on its own. And Kitware, the company that developed CMake, stemmed out of the BTK experience, and they still maintain BTK. Anyway, I'm spending a lot of time there because this was really my my gym, where I learned how to do open source, even though I didn't contribute back then because I was shy. I didn't know I was worth it, so I was just a user. And but then I moved to Canada for a year and something for my postdoc, and I landed in a lab where they were like, it was a private research institute connected to the university, the Roberts Research Institute in London, Ontario. And there I met with, it was 2003, I met with many people doing BTK with Python, Python probably 2 not a lot. But BTK already had wrappers for Python. So I kind of got into Python back then. And they taught me that, you know, you can make your own contribution, your own projects, and what releasing open source code means. So in the end, by the end of that experience in 2004, I released my own library, which is the Vascular Modeling Toolkit, which is basically a collection of everything I had created up until that point. For example, I created an algorithm for computing center lines in tubular shapes. So if you have a 3D model of something looking like a tube, I created a small algorithm to create the central line and the basically the envelope of spheres that fit that shape. And so the vascular modeling toolkit was a collection of that plus other algorithms, and it was written in Python and C++. That was 2004. And I'm not that involved anymore with BMTK, unfortunately, but it's still used. If you go to the bmtk.org website, there's a community of people that is, so it's not actively developed, but a lot of bioengineers around the world are using that software. So seemingly innocuous project that you just put out there because you saw others doing the same thing can really, be picked up. And the community doing that kind of stuff is not huge. It's not like the deep learning community. So it's not, the outreach of that is pretty limited. But within that community, that tool is still pretty used. So I think it's really important to realize that what you collected, like when you go on a beach, you collect pebbles, and that collection is really unique. So all the experiences that attached to you during your journey really make you a unique mix of expertise. So and so after this is somehow the way I feel about the situation I am in now, and I'll go, I'll take it a bit further if you're not bored by my recounting. I feel like an old person, back in blah blah blah. Anyway, because I am an old person. So after that experience, I came back in Italy, and I started a small imaging unit, a small lab in a research institute, dealing with medical imaging and helping clinicians do clinical research using medical image analysis, essentially. So I was supporting clinical trials and so on in this small team, and still developing BMTK up until when I realized I wanted a bit, to see what's beyond research and see how could I contribute to, helping more, with more algorithm and software stuff, not finalized to a paper, to a research paper, but enabling others to do things in a way, build tools for a living. Because at least at that time, building tools wasn't very highly regarded in research. Although one of my most cited papers is about the MTK, but in the end, you couldn't write, big grants on software stuff. Now it's changed, but back then it wasn't like that. And that was a time where I got into the Slicer community. So slicer.org. Slicer is a big software that is built on top of the MTK again. MBTK again. And that now the Slicer community has adopted the MTK a little bit, because there are many users there interested in the functionalities. And that's where I participated to a large community of people building a large software. That was the first time where I could sit in hackathons and so on. So it was really a formative experience for me. And that's when I eventually knew Bill Lorenzen, like met Bill Lorenzen, the BTK originator and watching film screen. That was a really good time of leveling up my open source realizations, and actually I was the one pushing Python in that community at the beginning. So I remember giving talks about the advantages of Python and so on. That was 2006, more or less. And in 2009, I decided to quit research and start my own company, which is Orobix. And Orobix is a company that is still alive and kicking. It's actually doing well here in Bergamo. And I started Orobix because I wanted to apply what I knew. So basically, there was no business idea around it except, I know some things, I want to do them professionally, and let's see what's happening, right? So, so don't start a company this way. That's my message. Have at least some kind of idea at the beginning. Otherwise you're gonna wander. If I think back about the chances we had to make it was really low, I think, because I remember when they asked me, what does Orobix do? And it took me like 20 minutes to kind of, have my, we're doing, imaging, but we're also doing software. But what makes you unique? Yeah, but we really do it. We didn't have a foundational idea. But at the same time, like I told you before, collecting pebbles along the way, that was a great way to collect a few more pebbles that I needed. So I started doing, learning how to code properly. I got into functional programming at that stage. That was the late 2000s, early 2010s. So I started getting involved in the Clojure community. Clojure, it's a Lisp based on the JVM. It's still, there are a few companies that are doing Clojure seriously. And it's a beautiful language. It's probably my favorite language, but I don't use it anymore. It taught me a lot. And there, I released a few libraries for Clojure. And I, at some point, I cobbled together something using JavaScript macros. So I built a bit of Clojure on top of JavaScript before ClojureScript was a thing. And that got on the front page of Hacker News for some reason. It was really funny. There were people doing podcasts about it, but then I didn't know how to continue with it, so I left it there. But it was an interesting experience, because you end up on the front page and then you whatever, you've done that and it's not so important in the end, right? So it's just something that happens by chance. And then Orobix was at the beginning, was involved in healthcare mainly, but we were doing a lot of medical image analysis as I was doing before. And we needed to, at some point, a pharma company from the US came to us. I remember they visited our very small office, but they came to us because of my prior research. So I could do some of the things that they needed in a particular domain for a particular disease. And so they gave us this huge data set of 4,000, huge for the time, 4,000 MRs, asking us to do something. And of course we said, yeah, sure, we can do it. But in the end, we spent a few months, struggling because we were applying traditional computer vision algorithms, but the variability in the data was too much. So we were using partial differential equations at the time, other things, but the statistical nature of that data really made us think that we needed to up-level our, to look for something else. And at the time, I had a student spending some time at the company who really was getting into deep learning, this first few things. And I said, yeah, let's try that, right? At the beginning, we tried with random forests. There was a guy in Cambridge who was really doing a great thing with random forests. We tried them. We actually implemented a C++ library implementing random forests and images, but they were kind of working at up to a point. And then this guy came and he said, no, this is the future. You need to try deep learning. It was 2012. And then I looked around for libraries. I found Torch 7, which had 3D convolutions because our data was 3D. It was the only library that had it. Probably Tiano had something, and Torch 7 was implemented in Lua. So C plus Lua. But the beauty of that is that it was really simple. Like you had the kernels in C, and then you had the Lua layer. You could inspect basically everything and look at how things were happening there. And so we started, and basically I was 37 or 38 at that point when I first got in touch with deep learning. So I was pretty old already. But very quickly we realized that we were putting our hands on something that could change the way we operated, because in a couple of months, 2-3 months, we already solved what we couldn't do in 8 months, struggling, trying different algorithms, putting them together, trying to make it work. Because the thing that characterizes deep learning is that the limiting factor for how complicated things can be is how much data you have and how good you are at instructing the algorithm learning. While before it was how smart you were in finding criteria that could work for your problem. But then if you had like 4,000 patients and all of them were different, it was really hard to put everything in your head and say, what are the criteria that make this organ and not something else when you have to extract it, segment it. So at that point, it was 2014, Orobix kind of changed, like pivoted after 5 years, pivoted towards becoming last mile AI company. So we wanted to do deep learning and apply to everything that we could apply to, and do it really in an applied way. And so we started doing manufacturing, healthcare, astrophysics, gaming. If you ever played MotoGP 19 game and subsequent MotoGP games, like we heavily contributed to creating the reinforcement learning algorithm that drives opponents. So it was really nice because we could do a lot of things, like going in the industry, guide a small robot, or doing quality control. And this is how we grow the company. Now the company is about 50 people, but we're still growing. So it's really growing strong on the applied side. But as you know, I've always been passionate about tooling and so on. So in this process, I got to know the Torch people. And then as soon as they released PyTorch, I was ready to, be involved more. And so I started contributing to the core, to the PyTorch core. Yeah. 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 Absolutely. Yeah. 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 I mean, part of me was pure nerdiness, like like I really liked it, but I would say that's a very good question. Probably if it was today, I couldn't contribute to Python because it's very large and also the processes are a bit more opaque because Facebook has a very large stake in it. So when you submit a PR, you don't like, yeah, you get good reviews and so on, but then it doesn't get merged immediately. It goes in the system and then it pops up and then it's merged. So you don't have full visibility. So it's a bit hard to kind of follow everything, although it's great, of course. Back then, I was frustrated with TensorFlow. So the story is that we had used Torch 7. Torch 7 was great because it was thin. So it was like the C kernels, C API, Lua on top. Lua is a very simple language. So you could really see everything, through it. And I really liked that about it when we were using it. But then our data scientists started to complain that they didn't like Lua. That it was always like exporting data from Python, reloading in Lua. It was really time consuming. And TensorFlow came out at some point, and I said, "Oh yeah, sure, let's try TensorFlow." And the experience was not pleasant for me because even the error messages. Sorry, I'm moving a few meters, otherwise there's too much sun.
Oh yeah, TensorFlow itself is rough.
Yeah, I mean, especially at the beginning, right? Where the TensorFlow 2 is a bit better, but TensorFlow 1, you basically had to learn another language on top of Python because it has its own graph abstraction. Then the error messages were like really large. And then there were people trying to build high-level stuff on top of it. That was good, but as soon as you needed something more, you went down like it was a very leaky abstraction. So you really needed to then learn TensorFlow anyway. So you had many things to juggle. But coming from the Torch 7 times, I said, it was so much simpler back then, and I'm not getting anything more for all this complexity. So when PyTorch came out, I said, finally, I can go back to my beloved Torch 7 stuff, but from Python. So let's, I wanted to make it, adopted it within Orobix, essentially. and the crazy thing with PyTorch is that the API basically didn't change, apart from a breaking change in 0.4 with variables. The API is pretty much what was back then. So, yeah, I mean, Sumit and Adam did an amazing job at figuring out what something that allowed simple things could look like, right? Sorry, I'm moving because it gets noisy here. It's a bar, so just let me.
Is that the new icon you have there?
Yeah, that's a lot of.
Center Sage? No, I think we lost him.
I think when he shifted places. Yeah.
Oh, yeah. He exited.
Don't panic. We completely left. Luca, you're back, and you're on mute again. You're on mute.
Yeah, this new office thing is throwing me off. Sorry.
No, but it's
really
better now.
get my act together. I hope it doesn't break up anymore because I was on a battery and the battery. Right. Sorry about that. Good. Yeah, let me know if there are other problems. Yeah, so we were talking about PyTorch and the way it was exceptionally stable. So, I mean, the design was so clean, and the fact that I could understand all the mechanics there made me want to contribute. It wasn't really strategic for me. It was just passion, and so at that point, for the pharma contract I told you about, I had to travel to the US. And the night before leaving, I sent a DM to Sumit saying, hey, we've been interacting a little bit. I'd like to buy you coffee. Because I already did something with PyTorch. It was like February, PyTorch was released in January. And so he invited me over at Facebook, and we had a chat there and so on. And that kind of solidified my enthusiasm for going in and starting to interact more, because I met some of the people and so on. But it was really quite natural. But the thing that really enriched me is that through PyTorch, I met some of the smartest people I've ever met. And it was a very humbling experience because they could understand things with a speed and depth that I would never dream about, right? But instead of saying yeah, whatever, it wanted to I wanted to hang out with them more because every interaction we had was so enriching. So in the end, I met Adam Pashke, who now is not contributing to PyTorch anymore, but he was basically the person who joined for a summer internship from Poland. At the time, he was a student. So, and Sumit wanted a summer intern to kind of to make a prototype of how Torch 7 would look like with PyTorch on top of it. So they get together in July, July 2016. And PyTorch was released in January 2017. So they developed everything that was there at that point in a very few months. And I remember Sumit saying that, he would they would chat with Adam at Facebook during the internship. And then, the meeting was over, and in the morning, and Sumit thought that Adam would take like 1 or 2 weeks to implement the stuff. But at the end of the day, he already implemented it, right? So I said, oh, wow, okay, let's go with the next step. So in a few weeks, the core of PyTorch was built. So I think the cleanness of the API and how tight it feels when you use it is really a testament to how good they were in the early days. And I think the huge traction that it had was because of a few factors. One is the design, for sure. I mean, it was clearly superior to TensorFlow 1. The second is that they kept the community really healthy. Like, I remember in the Slack,
channel, every time somebody was saying something, oh, TensorFlow guy, blah, ooh, TensorFlow, here, PyTorch, they would just, punish them, like, don't do this, because they wanted to keep the community really healthy and welcome. Very focused, of course. You couldn't be there, just like because you wanted to be there. But even if you ask the most basic questions, they would. And then I got to meet Thomas Wiemer after he joined, because he joined a few months later, and I'm still working with Thomas up until today. So big good friends with the PyTorch experience. And then as I was contributing to PyTorch, the offer to write the book from Anning came. And this book, the book we wrote with Eli Stevens, who I didn't know at the time. So Manning reached out, you want to write a book? I said, I have no time. Eli said, I have no time. And for some reason, Eli said, always says, for some reason, we thought that no time plus no time was time, but it's not like that. So we had to make time. It took a long time for us to write the book, but it was well received. So that further associated, the PyTorch experience with my experience. But then in 2018, I kept contributing. And this is something I want to talk about because it's really, I think, relevant. I was staying up at night to contribute to PyTorch. And then during the day, I had a lot of, Orobix was growing back then. It was about 10 to 20 people, that growth phase, which is really painful, according to me. Because at the beginning, you are kind of the center of a star, and you can coordinate people, delegate stuff. But when you go past a certain threshold, you cannot do that anymore. You have to create structure, and we didn't have that structure. So I was becoming the bottleneck for everything. And then I was very tired in the day because I was contributing to PyTorch at night. So I got grumpy, and the whole climate kind of spiraled. So at some point, I had to, I went through a bit of burnout, and I had to kind of stop contributing to PyTorch. And that was the time when more and more engineers from Facebook were joining PyTorch. Because at the beginning, it was really organic in a way that Facebook wasn't spending money on PyTorch, except Sumit's stipend, I think, and a few others. But they weren't putting any marketing efforts. They really wanted it to keep it home, Grid. How do you call it? Homebrew somehow. Now it's not like that anymore. But I think the first time Facebook started investing in it was the first PyTorch Developer Conference, which I believe was at the end of 2018. But up until that point, they didn't have a product manager and so on. It was purely, a very, very open source oriented, purely open source. So I stopped. Basically, I had to stop contributing to focus more on the company. But my kind of willingness to create tools kind of resumed at some point. So I got involved in creating a few tools for, not really for hardcore, the framework, but more what goes around it, because I was kind of realizing that there was a lot of room for tooling. So that's when I met Rick Izzo, who came in for an internship at Orobix, working on VMTK. So I wanted to resume some of the VMTK work. And he was a bioengineer in Buffalo. And he was one of the smartest, people that were interacting with the software. So I said, why don't you come over? There are a lot of things to refactor. You can come over and do the CI and some refactoring and so on. So he came, and at that point, I had started Redis AI, so kind of crossing Redis and frameworks for doing deep learning. Basically, I started with TensorFlow a number of years back, and then PyTorch and so on. So Redis AI was taking shape as a runtime environment, a serving engine. So it got interested in kind of that idea. And also we were starting to think about how data versioning would look like, how basically all traditional software engineering tools would translate to the ML world. How do you do testing in the ML world? And we talked a lot about those things. And we ended up creating a few prototypes, and we said, why don't we create a kind of a spin-off from Orobix, maybe based in the US, where we can explore this tooling space. And this is how TensorWork was born. So TensorWork was born in 2019. It was me and Rick. And I was more on the Redis AI side. Rick was started developing Hunger, and he wrote like 5 versions of it, starting from scratch. And Hunger is a tool. Now it's not actively developed for now, but we were developing that allows you to do data versioning in a way that is a lot more efficient than DBC, for example. DBC really took off. And Hunger I think it's a technically superior competitor to DBC, but we didn't have the kind of strength to push it the same way because we just started with the TensorWork. So it was the early days and so on. And then at some point I received a message, and I was spending a couple of days a week on TensorWork. And then I got in touch through the PyTorch community with sharing talks. And I said, are you interested in working with us at TensorWork? And it's funny because the way we got in touch with each other was that he wrote a book on PyTorch, Deep Learning with PyTorch. And he published it before our book. And at some point, and originally our book was called PyTorch in Action, with the In Action series at Manning. But then Manning wanted to do a more AI series and call it Deep Learning with. Then there were Francois Cholet with Deep Learning with Python, and they wanted to do Deep Learning with PyTorch, which incidentally is the same name Shannon used. So I reached out to Shannon on the PyTorch Slack and said, man, really sorry, they want to call my book, the name of my book, the same way as your book. And it was really, I thought he would be upset. And he, no, go, man, it's fine, it's great that for everyone. And so I said, yeah, wow, that's a nice guy. And then we started interacting, and that's how we got to work together at TensorWork. And he started contributing to both Redis AI, Hunger, and then he started his own Stockroom project, which was more like on top of Hunger, ML lifecycle. And then at some point in 2020, during the pandemic, Luis Capello from Grid.ai reached out and said, yeah, you're doing really nice stuff. Do you want to contract with us to do some of the things we need? Of course, it was our first real client, right? And a few months later, we decided to kind of merge with Grid. And this is how I Grid with Rick and Shannon, and we're heavily contributing to the Grid platform that lets you kind of run your deep learning jobs on the cloud the same way you run it on the laptop. So we want to eliminate the friction of going to the cloud to do initially training, and then there are other things, of course, that will come. And at the same time, we are developing PytorchLighning, and if you use Lightning on Grid, you get kind of more superpowers, but you can run anything quick, even Julia, for example. And so right now I'm VP of engineering, which means I'm kind of trying to make engineering flow, like work of engineering flow within the organization, both on the Lightning side, a bit less because they are very mature. So I don't interact a lot. Like I'm trying to, help from what I needed, but they really own the project. The Lightning Core team really owns the project. They're developed. The engineers are also on Flash, Lightning Flash, which is another project that we can talk about if you want. And then there's the Grid platform, which is absorbing a lot of my energies right now. And I'm kind of getting into this engineering organizations thing. Like I spent a lot of my life doing tooling and trying to, making an organization grow like Orobix. But right now, go ahead.
Sorry. Can I ask a question?
Of course.
Yep. So I think, your experiences, like, I really resonate with the part where you said, the collecting the pebbles, right? The experiences that happens to you.
Yeah.
So it seems like you have that breadth of experiences that help you in certain tasks, right? Like seeing a thing from multiple perspectives because of that particular experience, right? So, something I'm really passionate about is like deep tech, as in, really solid tech stuff. But I also like business and like, all the aspects of that, right? So, and like you mentioned, you started functional programming in 2008, Clojure, right? So, like, I had a concern that, do you think even, like, I'm not from a research background, like I have an engineering degree, but I did not get into research. But do you think even, 10 years from now, like if someone wanted to, they could switch into deep tech and, like they could, so I've this like stigma that, as you get older, it's harder to take in these deep tech topics, right? Like, would you be able to like, make something like the Bitcoin algorithm, if you're like 35 and you don't have like 10 years of deep tech experience. And and you seem to like defy that, bias that I have. So like, I would love to hear what your thoughts are on that.
Yeah. I mean, it's an excellent point. And I'm not saying that. So let's take a step back. I think you can get in the flow and really passionate about the one thing when you're younger, for sure. But that's where, you collect the pebbles. So to me, collecting pebbles is not necessarily doing bits and pieces, right? Small bites. Actually, my experience has been that the bite is usually 1 or 2 years long. Like you need to get into it, right? And really, focus on not only getting the surface, but getting the gist of things. And in order to do that, you can't just read a book. You need to go, and do it and dig and dig deep. So for sure, I think if you're young, also because when you're young, most often than not, you don't have kids, you don't have family around, so then life, it's a bit more complicated down the road. So it's a unique opportunity to just spend all your time on your sofa, just coding your way through without, having to care about other things and worry about it. But yeah, I think you can get to a higher perspective if you did your homework before, and your homework is going really deep into things, and not be anxious about doing the other things. Like, even when you collect pebbles and you're looking for the pink pebble, you're 100% focused on looking for the pink pebble. You're not saying, oh yeah, that's another, because at the end your pebble collection will suck, right? So you need to devote time to find the perfect pink pebble. And maybe you won't find the perfect one, but a really good one. And then you move on to the next pebble. And at the end, you will have a great collection. Otherwise, you'll have something that is bloated and anonymous and not significant. So yeah, I mean, I spent several years doing just one thing at a time. So, but I also think that after some time, there are different kinds of people. I'm not saying I'm the thing that it should be at all. Like it's all, I feel it was very serendipitous as I was saying. Most of what I've done happened completely by chance, and I didn't do all of it. Like, I'm not a superstar for sure, but I had fun in the process, so that's why. So, and I like where I am right now. So you need to not worry that you're spending time here and not there. Like that's the biggest thing. Also, if you're in machine learning, I've seen many people come in at Orobix and I've talked to them, and there's always this anxiety to say, okay, oh my gosh, now this new architecture came out, and now I need to look into that, and I was doing this, I was doing meta learning, but now I want to do transformers, and then now the new Google paper came out, and a new way of doing reinforcement learning, so I need to do that, and that's the best way to kind of lose yourself and not do anything significant. So I think, to me, collecting pebbles there is doing many things over a long stretch of time with the necessary depth. Because the next thing you do is not that it's uncorrelated with the previous one, right? It's not that they're all orthogonal. So the more you do things, having done something completely unrelated before, will give you a new perspective on how to do the second thing. And so your perspective will be richer and richer, because people that interact with you will recognize that you know how to think to have a side eye in things. And I think that's what makes a person that you interact with interesting, or pure depth makes it interesting. If you meet somebody who is exceptionally good at something, that is interesting per se. But there are also room for people like me that maybe are not, they go deep, but they're not exceptional at going deep, and those contributions that these other more wildcard type people is about enriching points of view and having kind of architectural view on things, because you've touched upon many things. So they're kind of a universal way in which complex systems are built. So no matter if you're talking about a neural network architecture or a distributed system or a software, architecture or whatever, there's something unifying there, which is how you manage complexity, how you manage persistent state, how you observe a state of a complex system evolving. And these are all things that come up all the time. So if you start seeing it in one scenario, and then you see it in another scenario, and then you see it in another scenario, you start seeing the pattern. But there's no reading it in the book. You need to experience it from yourself. I think that's I don't know, maybe I'm digressing, but that's what's really important to me.
Yeah, that makes sense. So the most important lesson is to not have kids. I'm just kidding.
No. When you have kids, at least my experience is that why did I do it before? Because it's life-changing, what did I do up until now? I had my first kid at 33. That was the year when I founded Orobix, actually. So that was a pretty transformative year. Also because I basically lost my job while my kid was being born. So my wife was really happy about that. I mean, I quit my job, not lost. But, I don't know. I think that I don't want to say something too naive, but there's nothing like having kids personally. It's so good. I mean, they give you, they makes you exhausted, but at the same time. And by the way, the reason why I'm in a room all by myself is because I have kids, because I can't work from home anymore. So when you're with them, you want to run away, but as soon as you step out of the door, then you say, it's too good.
The pink pebble is having kids,
Oh, it's a big pebble. It's a big pebble, and you need to carry it all the way. say.
Thank you. Thanks a lot for answering that.
No, that's good. So what's your thought? I mean, I'm asking the others as well. I hope I didn't bore you to death with recounting all my history, but I just wanted to add one more thing, which is the position I'm in now. Like I'm moving more, into seeing those kind of patterns. Since we've talked about patterns in complex systems, now apply to organizations, to engineering organizations or organizations as well, which is a technical topic. You know about Conway law? I don't know if you know about Conway. It was, formulated in the late 60s. And it's really simple. Like it says that your organization, if you're building software, the structure of your organization will be reflected in the structure of your software. So if you have 4 teams working on a compiler, you have a 4-stage compiler. So it's interesting because there are many implications of this. One of that is that if you want to reach a certain architecture in software, then you need to think about how you structure your team to reach that. And not only to structure the teams, but structure how the teams interact with each other, because the way they interact will be the way your software interacts. So building a successful, high-performing organization that delivers a product that is, that has all the right characteristics, really depends on how you build a team that will build that thing. And so everything related to software architecture and the way you want to, what you want to achieve in that, and how you want the various parts of the system to talk to each other, it reflects one-to-one on how you build a team that will make that. And I find this extremely engaging. So now my role is more on that side, and I try to advise on the architecture and how to go from here to there. Really depends on many factors, among which the way you structure the way people work, and the way they interact, the way they think about what they're doing, and the amount of context they have while they're doing it. And I've never thought about this in a formal way, and it just occurred to me that there's a vast literature of these things, lean management and so on, engineering organizations, that has matured over time. At the beginning was waterfall, then came agile, but then things are more like leaning towards something in the middle. So you went from all the way here to all the way there, and the pendulum has swung all to agile, everything bottom up and so on. But things don't really work that way. You need to have an architectural idea that you orient your ship towards, but to make an organization align so that we can produce that architectural idea is a process. Like it's like turning a ship. It's not like turning a motorcycle. Like, yep, you're there, you go there. No. It takes organic change. And by that, I mean introducing change little by little so that people in the organization will not perceive it as a dramatic change. But in the end of the maneuver, you reorient the whole thing towards you want to go. And so there's this lean manufacturing coming out of the 90s, 80s, 90s from manufacturing that is being applied to software engineering. And I think that's really fascinating because I've done a lot of interaction with manufacturing in my past with Orobix. I've seen a lot of lean manufacturing being applied on the field. And I feel that a lot of the concepts that I've read of people that have tried to do this parallel between lean manufacturing and the way software is built, is really interesting, and it resonates with my pebbles that I have in my bag. So now I'm really passionate about applying these things and leveraging on my experience to try to make the grid organization work in that way. I've seen a lot of opportunities in our growth, because now we will be growing really quickly. So those concepts, I hope, will help a lot in achieving the goals. I read a nice book which is called The Phoenix Project. Though maybe somebody of you will have read it. It's a novel about a guy who was on some mainframe system, minding about his business with the family, blah blah blah, and then he gets basically he gets taken into a responsibility role for an organization that wasn't working, right? And so that's the journey towards making the engineering organization work. And in doing so, it basically tells you you learn the point of view of lean management applied to software engineering.
Oh, Phoenix Project, right?
Phoenix Project, yeah. It's nice. It's a nice read. I read it this
Yeah, DevOps book. It was the book they give you to convince you to read the handbook.
Yeah, exactly. The DevOps. It was written in 2016.
It's a nice book. I wish my organization had read it.
Yeah. Yes.
It's like based on the goal or something that was for manufacturing.
Yeah, exactly. But yeah, I mean, many of you will not do this for some time, because I think you need to get there having experience. Like, the most effective way to get there as a role is having is understanding how complex software systems work. And open source is a great opportunity to do so, because you have full visibility of what's happening behind the scenes. Like, going back to the purpose of this chat about open source, right? I think what open source gives you is the ability to go as deep as you want. Because if you learn how to use systems from an enterprise standpoint, you will always hit a wall where you don't know what's beneath the surface, and that will teach you many things, but it won't teach you how to build systems, complex systems that can be one project, many projects together, or an organization. And then what are the patterns with which those subsystems can interact, and on one end. And then the other thing the open source tells you is not just the visibility of what's there at some point in time, but also how does a successful project evolve in time. Because the evolution of a complex system is an issue that that even for open source software hinges on humans. Like, it's a heavily soft skill and human heavy experience. You read a lot about open source maintainers being frustrated about reactions from the community and so on. So there's so many dynamics that if you have a good grasp of those, then it's a big pebble you collect. So getting into the open source, and I was mentioning before, the experience with in part the right perspective on the way the open source community reacted to things like Boo, TensorFlow, Go, PyTorch, and that thing I was telling before. This is you learn by being heavily involved in an open source project, and by then I mean you choose one and you devote your nights to it, or your days to it, or weekends, or a significant amount of time to it, and not just do tapas around many. I mean, you can also do it, but you don't learn so much. But if you're heavily involved in one, then you learn how to recognize, or you have better information how to recognize the seeds of toxicity that are there in organizations, they're there in open source projects, and so on. You may find that things spiral out of control, out of seemingly innocuous thing that you wrote off somehow. Yeah, sure, these two are fighting about stuff, but that's the way things go. And then all of a sudden, 2 months later, you turn around and say, "Oh, wow, the atmosphere is terrible here." So what happened, right? And this is the same thing in companies. It's the exact same thing. So one thing I do is whenever I recognize something really, the lizard sense of things not, dynamics not being correct, I push back really heavily, even in the organization inside me. So I really fight them with as much strength as I can, because I know that the highest risk of an open source project of a company is to have its culture drift away. So participating to open source is not just an opportunity to grow technically, but also a big lesson around how to build the right kind of culture that you can apply to open source and to enterprise, big enterprise, small startups. It's so important. And even if you're technically superior, which I seldom was in my past, but if you're technically superior, you need to be able to gauge your communication so that everything keeps being constructive. Otherwise, for example, if in a company you're the point of reference for too many people, you'll become a bottleneck in no time, because nobody will take a decision on their own and they will lean on you for every single thing. Which not only is bad because you have a limited capacity, and this is the same problem, but because the diversity of that thing will go down dramatically. The company will be an extension of the way you think, and this is terrible. It's not good. Because it's not possible for you to see the flip side of things. And I think that's one of the most important things to have, like diversity of thought, diversity of all the other things that we know when we speak about diversity. So to have the right amount of female present, which I'm not finding here, but it's not a blame, is that it would be nice, it would be enriching, right? But it's not easy. So why are not more female in this group? Well, it's not, it's not Jitin's fault or anyone's fault right now. But I think that, we need to change it from somewhere, right? So the health of complex systems comes from, diversity as well. So this is another aspect that, lowers the risk of things spiraling out of control. And you can see in projects getting bloated, the open source project getting bloated, that the bloat, maybe not 100%, but very often comes from dynamics being not healthy. So there's such a strong parallel I see from the dynamics you establish and the quality and the cleanness of the end product, of the end result. That's really staggering to me. And this is something you learn in being within the open source project. I talk too much. I know. I was very excited for this chat, so I keep talking. Stop me.
I have a question.
Yeah.
Oh, well, you said that one of the key components is gathering pebbles, right? Well, how can you make sure that this pebble, this certain repository, this certain company, you've devoted ample time and ample resources to go to the next one? How would you decide yourself to go to the next step?
Yeah, that's there are two sides of it: how you choose and how you decide to move on. Well, how you choose is, I think there's 20% strategy and 80% curiosity. That's the mix. I'm not saying that it needs to be 100% curiosity, because that wouldn't be fair. I think you need to think strategically about what could, be where you want to be at some point. After this experience, or what visibility you want to gain, or if you're not interested in that at all, but it must be 20% or more. And then passion, because this is the thing you will need to stick with for a long time. Otherwise, you won't be able to. So sheer curiosity and passion are essential. For example, right now in deep learning, I would devote my time to contributing to either the tooling space, many tools out there, or the ecosystem, which is a bit of tooling. Like if you go, for example, on the PyTorch ecosystem, there are a number of projects that are very small, understandable. They're already in the PyTorch ecosystem. One of the last things I did with Thomas Wieman is Torch Drift, which is a project to detect drift in data or models, model outputs. And it got into the ecosystem, and Facebook is very, is helping us with some visibility. But that's a very small project, and but it has its utility. So there are so many things that are outside PyTorch that are needing contributors, even Flash, Lightning Flash. It's an amazing opportunity because you can create a new task, like video segmentation, or it's task-based. So you implement a certain task, like audio recognition, or a very specific one. Then you can train backbones and make them available. This is the kind of thing that smaller scope, but I think big return of investment for yourself and others. How you decide to move on? I don't know. It's very personal, I think. I think you should always take good care of yourself. So if you see that it's giving you anxiety, and this thing persists, like anxiety in the sense not of programming. I mean, like you have too much on your plate, you're becoming like a bottleneck, or you don't think about it as something you're eager to do, but something that, oh my gosh, I have that thing, and now it's been there for a while, and I can't get back to it. Then you need to stop, and because there's a nice sentence I read yesterday. It's from, I don't remember from whom, but from the Dalai Lama. It was a citation, and it was long, but at the end it said one of the things that I was most struck with the Western culture is that he said a number of things, and then he said the Western person, or the modern person, he referred it to Western because he took his first trip, but I think it applies to everyone in this space. Is that people live like they will never die, and die like they never lived, and it's really striking, right? So you need to make time for yourself, and you move on when it's time to move on. You need to recognize the signs. Is it because you burned out? Is it because your heart is in something else? And maybe you can give yourself a bit more time. Like, I think these things are developed in a time scale of months, not a week. Like, if you're tired for a week, that's not it. But if you recognize the sign for 3-4 months, I think you owe yourself to take a break at least, and then explore the vastness of the world and how interesting it is, and where you can make where you can collect pebbles again. I don't know. I think you should just let it flow. And again, it's the same thing as I was saying with the ML papers, right? You know, you shouldn't stay up at night trying to read as many papers as they come out, because it's probably not a good use of your time. What you need to recognize is the underlying pattern. And you can get that by focusing on one of these things and try to push away all the noise that is coming to you. And maybe there will be a time in which you get into transformers, but it's not for now. Right? And it goes back to lean manufacturing and lean management, because you always need to work at the constraint. All the work done away from the constraint, it's time that you're losing. So to me, the constraint is the problem that I'm passionate about at that point in time. I don't know, maybe, you know, it works. It works like that. For me, I don't always recognize things, but that's, I think, the thing we should at least strive to live a good life in the first place.
Yeah, thank you so much. Yeah.
Sounds like what that book does as optimizing flow or something.
Yeah, exactly. Optimizing flow. It applies to everything, exactly, right? So read that Phoenix book project, because you can apply to engineering, but you can apply to really beyond, you know, that.
It is a fun read.
Yeah. I mean, it's not the Bible. I'm just saying that, you know, it's useful. It's a useful read. I don't live by the book. Okay, I just read it. but it resonated in many things. Anyway. No, thank you.
Specifically love the pebble analogy. I will be using that a lot.
Yeah, good. Thanks a lot, guys. It's been really a pleasure, and I hope we will be in touch some other time.
Yep. So is that pebble analogy yours? Is that pebble analogy yours, or did you read it somewhere?
I'm sure I wasn't the first to come up with it, for sure. But I actually thought about it when we were speaking earlier. So metaphor, and I landed on that one.
Perfect. Then I know if I write it somewhere, I know I should cite you. You know.
No. I'm sure probably I don't even realize, but probably I heard it somewhere in my head, like. So.
Thank you.